Picture this. A team of Princeton physicists switched on their equipment one morning, expecting routine measurements from a material thinner than a human hair. Instead, they discovered something that made them question everything they thought they knew about reality. The material was behaving in ways that defied their most sophisticated theories, as if the universe itself was keeping secrets that only emerge when we dare to trust its strangest rules completely. What they found challenges the very foundation of how we understand the physical world, and it's just one of dozens of recent discoveries suggesting that when we fully embrace quantum mechanics, rather than treating it as a curious mathematical tool, reality becomes far stranger and more beautiful than we ever imagined. I'm here to take you on a journey through the most mind-bending discoveries happening right now in quantum physics places, where trusting the equations leads to phenomena so extraordinary they sound like science fiction. Yet they're unfolding in laboratories around the world every single day. Before we begin, let me say this. You don't need to understand complex mathematics or have a physics degree to appreciate what's happening here. These discoveries aren't just changing science, they're revealing something profound about the nature of existence itself, something that touches every aspect of how we experience reality. So settle in, take a breath, and prepare to see the universe through a lens that will forever change how you think about the world around you. Let's begin with that Princeton discovery, because it perfectly illustrates what happens when reality decides to surprise us. The researchers were working with a material called twisted bilayer graphene, essentially two sheets of carbon atoms stacked and rotated at a precise angle. This creates what physicists call a magic angle structure that's only 3 atoms thick. On paper, this material should behave predictably. When cooled to near absolute zero, it becomes a superconductor, allowing electricity to flow without resistance. The theories describing this behavior, developed over decades and tested countless times, painted a clear picture of what should happen. But the universe had other plans. When the team began their measurements, they discovered something that made them double-check their equipment multiple times. The material was exhibiting quantum behaviors that shouldn't exist according to their best theoretical frameworks. Vortices, tiny whirlpools of magnetic field, were appearing at temperatures and conditions where they had no business existing. Even more puzzling, these quantum signatures would suddenly vanish when the researchers adjusted the electron density by the smallest amount. One moment the system displayed clear quantum properties, the next moment they disappeared entirely, as if someone had flipped a cosmic switch. Dr. Yazdani, the lead researcher, described it as discovering a new frontier where their understanding simply broke down. The equations that had successfully described similar materials for decades were suddenly inadequate, like trying to navigate with a map of a completely different territory. This isn't an isolated incident. Across the globe, physicists are encountering similar surprises when they trust quantum mechanics to its logical conclusions rather than limiting it to the microscopic realm where we are comfortable with its strangeness. Consider what happened when researchers at MIT began investigating something called fractional quantum charges. In our everyday experience, electric charge comes in whole units. An electron carries 1 unit of negative charge. A proton carries 1 unit of positive charge. It's as fundamental as counting apples or coins. But when MIT physicists created specific conditions in ultra-thin graphene layers, they discovered electrons that appeared to carry fractions of their normal charge. Not half an electron, not a third of an electron, but genuine fractional charges that emerged from the quantum mechanical interactions between particles. Think about that for a moment. The very concept of electric charge, something we consider as basic as the difference between positive and negative, becomes fluid and divisible under quantum conditions. It's as if the universe is telling us that even our most fundamental categories are suggestions rather than absolute rules. As you listen to this, notice how these discoveries might challenge your own assumptions about what's fixed and what's flexible in the world around you. The boundaries we take for granted in everyday life may be far more permeable than we realize. The strangeness doesn't stop with exotic laboratory materials. Quantum mechanics is revealing hidden behaviors in substances we encounter every day. Behaviors that emerge only when we trust a theory enough to look for them. Take insulators, materials that shouldn't conduct electricity under any normal circumstances. Rubber, glass, ceramics, these materials form the backbone of our electrical safety systems precisely because they block the flow of electrical current. Yet an international team of researchers recently discovered something that overturns this basic classification. When subjected to powerful magnetic fields, certain insulators begin exhibiting quantum oscillations, the same signatures that appear in metals. These materials are somehow conducting electricity through their interior, not just on their surface in ways that classical physics says should be impossible. Imagine discovering that the rubber insulation around electrical wires could suddenly become conductive under specific conditions. Not because it's been damaged or contaminated, but because quantum mechanics allows it to access hidden states of conductivity that exist parallel to its normal insulating properties. This discovery forces us to reconsider the fundamental distinction between conductors and insulators. Categories that seemed absolute and unchanging turn out to be contextual, dependent on conditions that reveal the quantum nature hidden within ordinary matter. The implications ripple outward in unexpected directions. If materials can access quantum states that classical physics says shouldn't exist, what other hidden properties might everyday objects possess? What capabilities lie dormant in the world around us, waiting for the right quantum conditions to emerge? This question becomes even more intriguing when we consider recent experiments with quantum levitation. In a demonstration that captured worldwide attention, researchers in the Netherlands successfully levitated a living frog using quantum mechanical principles. The frog hovered motionless in mid-air, completely unharmed, suspended by forces that emerge from the quantum properties of superconducting materials interacting with the diamagnetic properties of biological tissue. The sight of a frog floating serenely above a magnetic field represents more than just a clever physics demonstration. It reveals that quantum effects can manifest at scales much larger than individual particles, influencing objects we can see and touch in ways that seem to defy gravity itself. The frog experiment hints at a deeper truth about quantum mechanics. When we trust its principles completely, rather than limiting them to atomic and subatomic scales, we discover that the boundary between quantum and classical behavior is not a sharp line, but a fluid frontier that depends on conditions, context, and our willingness to explore the implications of the theory. Perhaps nowhere does trusting quantum mechanics lead to stranger implications than in its relationship with consciousness and observation. The role of measurement in quantum mechanics has puzzled physicists since the theory's inception, raising questions that blur the boundary between physics and philosophy. According to the Copenhagen interpretation, one of the most widely accepted frameworks for understanding quantum mechanics, the act of observation plays a fundamental role in determining reality. Before measurement, quantum systems exist in superposition, simultaneously occupying multiple states. The act of observation collapses this superposition into a single, definite outcome. But this raises a profound question. What constitutes observation? Does it require a conscious observer, or can any interaction with the environment cause collapse? The answer remains one of the deepest mysteries in physics, with implications that extend far beyond laboratory experiments. Some interpretations hypothesize that consciousness might involve quantum-like processes. Roger Penrose, the renowned physicist and mathematician, has proposed that consciousness arises from quantum processes occurring in microtubules within brain cells. According to this speculative idea, the collapse of quantum wave functions in neural structures gives rise to conscious experience. While this remains unproven and controversial within the scientific community, recent experimental results have found evidence of quantum-like processes in biological systems, including some neural structures. This doesn't prove that consciousness is quantum mechanical, but it suggests that the boundary between quantum and classical systems in biology is more complex than previously thought. The implications are staggering if we trust quantum mechanics to its logical conclusions. Rather than consciousness emerging from purely classical brain processes, our subjective experience might be intimately connected to the fundamental quantum nature of reality. We might not simply observe the quantum world, we might participate in it at the deepest level. Take a moment to consider what this might mean for your own experience right now. As you listen to these words, quantum processes are occurring throughout your brain, in the synapses between neurons, in the molecular machinery of your cells. If consciousness does involve quantum processes, then your awareness could be understood as participating in the same quantum reality we're discussing. You're part of it. This connection between consciousness and quantum mechanics becomes even more intriguing when we consider the phenomenon of quantum contextuality. Unlike classical objects, which have definite properties independent of how we observe them, quantum systems seem to possess properties that exist only within the context of measurement. Think of it this way: a classical coin is either heads or tails, whether you look at it or not. But a quantum coin might be neither heads nor tails until the moment you decide to check, and the way you choose to check might influence what you find. The properties don't exist independently of the measurement context. If consciousness participates in creating the context for quantum measurements, then our awareness might play an active role in shaping the reality we experience. This is highly speculative and far from proven, but it emerges naturally when we follow quantum mechanical principles to their logical conclusions without limiting ourselves to classical assumptions about the separation between observer and observed. Perhaps the most mind-bending consequence of trusting quantum mechanics completely involves its relationship with time itself. Recent experiments have revealed phenomena that challenge our most basic assumptions about the flow of causality and the relationship between cause and effect. At CERN, the world's most powerful particle accelerator, researchers have observed anomalies that suggest the possibility of retrocausality, effects that appear to precede their causes. In high-energy particle collisions, certain patterns emerge that could imply information travelling backward in time, creating influences that reach into the past to affect their own origins. While these results are still being analysed and debated, and skeptics caution that they might arise from experimental errors or unknown variables, the tantalising possibility cannot be dismissed outright. If confirmed, these observations would reveal that quantum mechanics allows for temporal relationships that violate our everyday understanding of how time works. The implications extend beyond exotic particle physics experiments. Quantum mechanics has always contained hints that time might be more flexible than we assume. The famous delayed choice experiments demonstrate that decisions made after a quantum event has occurred can seem to retroactively influence the nature of that event. Imagine setting up an experiment where a photon passes through a double slit, creating an interference pattern that proves it behaved like a wave. But then, after the photon has already passed through the slits, you decide to measure which slit it used. Quantum mechanics suggests that your later decision to measure will retroactively determine whether the photon behaved like a wave or a particle, even though that behaviour occurred before you made your choice. This isn't time travel in the science fiction sense. You can't use these effects to send messages to the past or change historical events, but they suggest that the quantum world operates according to temporal relationships that our classical intuitions cannot grasp. Causality becomes contextual, dependent on the complete experimental setup, rather than following the simple linear sequence we experience in everyday life. When we trust quantum mechanics completely, we must accept that time itself might be more of a suggestion than an absolute constraint. The future might reach back to influence the past, not through dramatic alterations, but through subtle quantum correlations that exist outside our normal experience of temporal flow. As you contemplate this idea, consider how it might apply to your own experience of time. Have you ever had moments where the future seemed to inform the present, where an outcome appeared to cast shadows backward into your decision-making process? While this remains metaphorical rather than literal, quantum mechanics suggests that such temporal flexibility might be more fundamental to reality than we typically assume. One of the most revolutionary insights emerging from trusting quantum mechanics completely involves reconceptualizing the universe not as a collection of things, but as a flow of information. This perspective transforms our understanding of reality from a mechanical clockwork to something more akin to a cosmic conversation. Quantum entanglement provides the clearest example of this information-based view of reality. When two particles become entangled, they form a connection that transcends space and time. Measuring one particle instantly affects its partner, regardless of the distance between them. Einstein famously called this spooky action at a distance, but modern physicists understand it as evidence that information, not matter or energy, forms the fundamental substrate of reality. Recent experiments have pushed quantum entanglement to unprecedented scales. Teams of researchers have successfully created entangled states involving thousands of particles, massive quantum systems, where the measurement of one component instantly influences all the others. These experiments demonstrate that the spookiness Einstein found so troubling scales up to include systems we can see and manipulate directly. But the true strangeness emerges when we consider what this means for the nature of space itself. If entangled particles can influence each other instantaneously across vast distances, then the space between them isn't empty separation, but rather a medium through which quantum information flows. Some physicists now speculate that space itself might be woven from quantum entanglement, that the fabric of space-time emerges from information relationships rather than existing as a background stage for physical events. This information-theoretic view of reality gains support from discoveries in quantum computing, where researchers have found that entanglement provides computational advantages that seem to transcend the physical limitations of classical machines. Quantum computers don't just process information faster, they access information relationships that don't exist in classical systems. The implications ripple through our understanding of consciousness, identity, and existence itself. If reality is fundamentally informational, then consciousness might not be something that emerges from matter, but rather a particular way of organizing and processing quantum information. We might be patterns in the cosmic flow of information rather than separate entities observing an external world. Take a breath and consider this possibility. The thoughts occurring in your mind right now, the subjective experience of understanding these concepts, might represent quantum information processing that connects you directly to the fundamental information structure of the universe. You're not just learning about quantum mechanics. You might be participating in the quantum information flow that constitutes reality itself. Recent research in quantum biology supports this information-centric view. Studies of photosynthesis have revealed that plants use quantum coherence to process information about light energy with remarkable efficiency. Birds appear to use quantum entanglement in their navigation systems, accessing information about magnetic fields through quantum processes in their retinas. Even the human brain shows signatures of quantum information processing in certain neural microtubules. If consciousness involves quantum information processing, then trusting quantum mechanics completely might mean recognizing that our awareness represents a localized intensification of the universe's capacity to know itself. We might be points where cosmic information achieves self-reflection, temporary focal points in a vast information field that encompasses all of reality. This perspective transforms questions about the meaning and purpose of existence. Rather than asking why the universe exists, we might ask what the universe is trying to understand about itself through the emergence of conscious observers. Rather than seeing ourselves as accidents in a meaningless cosmos, we might recognize ourselves as essential participants in the universe's quest for self-knowledge. This exploration has only begun to scratch the surface of what happens when we trust quantum mechanics completely. We've seen how materials break their own rules, how consciousness might participate in shaping reality, how time becomes negotiable, and how information might form the fundamental substrate of existence. But there's so much more to discover. The quantum world holds secrets that challenge every assumption we make about the nature of reality, consciousness, and our place in the cosmos. In our next exploration, we'll delve even deeper into the mystery of how quantum mechanics might be speaking directly to your subconscious mind through the language of dreams. Until then, rest well, knowing that the universe is far stranger and more wonderful than we ever dared imagine. And remember, every time you trust in possibilities that seem impossible, you're participating in the same leap of faith that has led to humanity's most profound discoveries about the nature of reality itself. Sweet dreams, and quantum dreams at that. Deep in laboratories around the world, physicists are grappling with a mystery that becomes more puzzling the more we understand it. It's called the measurement problem, and it reveals something so fundamental about reality that it challenges the very notion of what it means for something to exist. Here's the paradox. Quantum systems evolve according to precise, deterministic equations. The mathematics is elegant, predictable, and incredibly accurate. Yet every time we measure a quantum system, we get results that appear completely random. It's as if the universe operates like a perfect clockwork mechanism until the moment someone looks, and then it starts rolling dice. Consider an electron spinning around an atomic nucleus. According to quantum mechanics, before measurement, this electron exists in what physicists call a superposition of all possible spin states. It's not spinning up or down or sideways. It's spinning in every direction simultaneously, a ghostly dance of pure possibility. But the moment you measure its spin, something extraordinary happens. The superposition collapses, and you find the electron spinning in one definite direction. The universe seems to make an instantaneous choice, selecting one reality from the infinite menu of possibilities. What makes this even stranger is that the choice appears to be genuinely random. Not random because we lack information, but fundamentally, irreducibly random. The universe appears to be making decisions by consulting some cosmic coin flip that exists beyond our ability to predict or understand. Recent experiments at the University of Vienna have pushed this mystery to unprecedented scales. Researchers created quantum superpositions involving molecules containing over 2,000 atoms. These massive quantum objects, visible under powerful microscopes, demonstrated the same inexplicable behavior as individual particles. Before measurement, they existed in multiple states simultaneously. After measurement, they collapsed into single, definite configurations. The implications ripple outward in ways that challenge our deepest assumptions about the nature of existence. If measurement plays such a fundamental role in determining reality, then what counts as measurement? Does it require conscious observation, or can any interaction with the environment trigger collapse? As you ponder this question, notice how it might relate to your own experience of making decisions. Have you ever felt suspended between multiple possibilities as if different futures existed simultaneously until the moment you committed to a choice? While this remains metaphorical rather than literal, quantum mechanics suggests that such states of suspended possibility might be more fundamental to reality than our classical intuitions assume. Some physicists have proposed that consciousness itself plays a special role in quantum measurement. This interpretation suggests that the universe exists in a state of pure potential until conscious observers collapse the wave function through the act of observation. We become co-creators of reality, participants in an ongoing dialogue between mind and cosmos. Other interpretations avoid this consciousness-centric view by proposing that any interaction with the environment can cause collapse. In this picture, the universe is constantly measuring itself through countless microscopic interactions, creating reality through an endless cascade of quantum decisions that occur whether we're watching or not. Perhaps the most radical solution to the measurement problem comes from an interpretation that takes quantum mechanics so seriously it multiplies reality itself. The many worlds interpretation suggests that wave functions never actually collapse. Instead, every possible outcome of every quantum measurement actually occurs, each in its own parallel universe. According to this view, when you measure that spinning electron, you don't force it to choose between up and down. Instead, the universe splits. In one branch, you observe spin up. In another branch, an identical copy of you observes spin down. Both outcomes are equally real, equally valid, equally you. This interpretation emerged from the work of physicist Hugh Everett III, who in 1957 proposed that the universal wave function never collapses. Instead, it continues evolving according to the Schrödinger equation, branching into parallel realities with every quantum event. Everett called it the relative state formulation, but it became known as the many worlds interpretation. If we trust this interpretation completely, then reality becomes incomprehensibly vast. Every quantum event, from the decay of a radioactive atom to the firing of a neuron in your brain splits the universe into multiple parallel branches. The number of parallel worlds grows exponentially with each passing moment, creating a multiverse of staggering complexity and beauty. Think about what this might mean for the choices you make in your daily life. In the many worlds interpretation, every decision point represents a quantum measurement that splits reality. In one world, you chose to listen to this video. In another, you decided to do something else entirely. Both versions of you are equally real, living out their experiences in parallel universes that can never communicate with each other. Recent research in quantum computing has lent some support to the many worlds interpretation. Quantum computers seem to derive their power from exploring multiple computational paths simultaneously, as if they're accessing the parallel processing power of alternate realities. While this doesn't prove the existence of parallel worlds, it suggests that quantum systems naturally explore multiple possibilities in ways that classical systems cannot. The many worlds interpretation also offers a unique perspective on probability and chance. In this view, everything that can happen does happen. The randomness we observe in quantum measurements isn't fundamental randomness, but rather our subjective experience of finding ourselves in one particular branch of reality. From the multiverse perspective, all outcomes are equally real and equally probable. This raises profound questions about identity, consciousness, and free will. If countless versions of you exist across parallel worlds, making different choices and experiencing different outcomes, what makes your particular version of events special? Are you responsible for decisions made by alternate versions of yourself in parallel universes? While these questions venture into philosophy rather than physics, they emerge naturally from trusting quantum mechanics to its logical conclusions. The universe revealed by quantum theory is so much stranger and more wonderful than our classical intuitions that it challenges every assumption we make about the nature of existence. To understand what happens when we trust quantum mechanics completely, we need to venture into one of its most counterintuitive predictions: the idea that empty space isn't actually empty. According to quantum field theory, what we perceive as vacuum is actually a seething sea of activity, filled with particles that pop into existence and vanish again in time frames too brief for direct observation. These virtual particles, as physicists call them, arise from quantum fluctuations in the underlying fields that permeate all of space. They appear in pairs, a particle and its antiparticle, borrow energy from the vacuum, dance briefly in existence, and then annihilate each other, paying back the energy debt before the universe notices the violation. This might sound like theoretical speculation, but these virtual particles have measurable effects on the real world. They alter the energy levels of electrons in atoms, create forces between metal plates in vacuum, and contribute to the magnetic properties of fundamental particles. The universe is constantly buzzing with invisible activity that shapes the reality we experience. Consider the implications of this discovery: the space between the words on this page, the air between your fingers, the vast emptiness between stars. None of it is truly empty. It's filled with a constant dance of creation and annihilation, a quantum choreography that never stops. Reality is far more dynamic and alive than our senses can perceive. Recent experiments have pushed our understanding of vacuum fluctuations to new extremes. Researchers have found evidence that these quantum effects can influence the behavior of materials in unexpected ways, causing insulators to conduct electricity and creating new phases of matter that shouldn't exist according to classical physics. As you breathe right now, quantum fields are fluctuating through your body. Virtual particles are appearing and disappearing in the space between your cells, and the vacuum itself is contributing to the forces that hold your atoms together. You exist not in empty space, but in a rich tapestry of quantum activity that connects you to the fundamental energy of the universe. Some interpretations of quantum field theory suggest that consciousness itself might emerge from particular patterns in these quantum fluctuations. While this remains highly speculative and lacks scientific consensus, it raises intriguing questions about the relationship between mind and the quantum vacuum. Could awareness be a way the universe develops the capacity to observe its own quantum fluctuations? In 2012, Nobel Prize-winning physicist Frank Wilczek proposed something that seemed impossible: a form of matter that could exhibit periodic motion in its ground state, breaking time translation symmetry while consuming no energy. He called these hypothetical structures time crystals, and most physicists assumed they couldn't exist. They were wrong. In 2016, researchers at the University of Maryland successfully created the first time crystal, a system of trapped ions that exhibited repeating patterns in time rather than space. Unlike ordinary crystals, which have periodic structures that repeat in spatial dimensions, time crystals have structures that repeat in the temporal dimension, creating a form of motion that persists without energy input. Time crystals represent a fundamentally new phase of matter, one that challenges our understanding of equilibrium, energy, and the nature of time itself. They exist in a state of perpetual motion that doesn't decay, doesn't consume energy, and doesn't reach thermal equilibrium with their environment. It's as if they've found a way to step outside the normal flow of thermodynamics while remaining part of our physical reality. The creation of time crystals required trusting quantum mechanics to predict states of matter that classical physics said were impossible. Researchers had to believe that quantum systems could organize themselves in ways that violated classical intuitions about energy, motion, and stability. Recent advances have pushed time crystal research in even stranger directions. Scientists have created time crystals with multiple temporal dimensions, systems that exhibit periodic behavior in several different timescales simultaneously. These multidimensional temporal crystals exist in states so far removed from everyday experience that we lack adequate language to describe them. Think about what this might mean for your own relationship with time. We typically experience time as a linear flow from past to future, with events unfolding in irreversible sequence. But time crystals suggest that matter can organize itself in ways that create periodic patterns in time, regions where temporal relationships become cyclical rather than linear. While this doesn't mean you can travel through time or escape the aging process, it does suggest that time itself might be more flexible and structured than our everyday experience suggests. The universe contains pockets where temporal relationships follow rules that differ from our normal experience of causality and change. Time crystals also hold promise for technological applications. Because they maintain coherent quantum states without energy input, they could serve as the basis for quantum computers that operate with unprecedented efficiency. They represent a bridge between the theoretical predictions of quantum mechanics and practical technologies that could transform our understanding of information processing. One of the most mind-bending consequences of trusting quantum mechanics completely involves the relationship between information, space, and reality itself. Recent developments in theoretical physics suggest that our three-dimensional reality might be a projection from information encoded on a two-dimensional surface, like a hologram that exists at the boundary of our observable universe. This holographic principle emerged from studies of black holes, those mysterious regions where gravity becomes so strong that nothing, not even light, can escape. Physicists discovered that all the information that falls into a black hole appears to be encoded on its two-dimensional surface, rather than distributed throughout its three-dimensional volume. If this principle applies to the entire universe, then everything we experience as three-dimensional reality might actually be information projected from a distant two-dimensional boundary. The depth, volume, and spatial relationships we take for granted could be emergent properties of information processing occurring on a cosmic holographic screen. This isn't just theoretical speculation. Recent experiments in condensed matter physics have created laboratory versions of holographic systems, where the behavior of three-dimensional materials can be perfectly described by information processing occurring on their two-dimensional boundaries. These experiments suggest that holographic relationships might be a fundamental feature of quantum reality. Consider what this might mean for your own existence. If the holographic principle is correct, then your three-dimensional body, your spatial relationships with the world around you, even the volume of space you occupy, might all be projections from information encoded elsewhere. You might be a pattern in a cosmic information field rather than a collection of particles occupying space. This perspective transforms questions about consciousness and identity. Rather than asking where consciousness is located in the brain, we might ask how awareness emerges from information patterns that exist at the holographic boundary of reality. Rather than thinking of ourselves as separate entities, we might recognize ourselves as interconnected aspects of a unified information field. The holographic principle also suggests that the amount of information that can be stored in any region of space is limited not by its volume, but by the area of its boundary. This places fundamental constraints on the complexity of physical systems and might explain why certain quantum states cannot be achieved or maintained in large systems. As you contemplate these ideas, take a moment to notice your immediate sensory experience. The feeling of three-dimensional depth, the sense of objects existing at various distances from you, the apparent solidity of the world around you. All of this might be a sophisticated projection from information processing occurring at scales and locations far beyond your direct perception. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. The journey we're taking together requires patience and openness to ideas that challenge our most basic assumptions about reality, and members help ensure this exploration can continue at its natural pace. The holographic universe also raises profound questions about the nature of locality and non-locality in quantum mechanics. If information at the boundary determines everything that happens in the interior, then quantum entanglement might be a natural consequence of the holographic structure of reality rather than a mysterious violation of local causality. Perhaps the most surprising frontier in quantum mechanics involves its role in living systems. For decades, physicists assumed that the warm, noisy environment inside biological cells would quickly destroy any quantum effects. Life, it seemed, operated according to classical physics, with quantum mechanics relegated to the microscopic realm of atoms and molecules. They were spectacularly wrong. Recent discoveries have revealed that life not only tolerates quantum effects, but actively exploits them for enhanced efficiency and capability Plants use quantum coherence to optimize energy transfer during photosynthesis. Birds navigate using quantum entanglement in specialized proteins in their eyes. Even human consciousness might involve quantum processes occurring in neural microtubules. The discovery of quantum effects in photosynthesis represents one of the most elegant examples of life harnessing quantum mechanics. When sunlight strikes a chlorophyll molecule, it creates an energy packet that must travel through a complex molecular maze to reach the reaction center, where it can be converted into chemical energy. Classical physics suggests this energy should take a random walk through the system, losing efficiency through trial and error. Instead, quantum mechanics allows the energy to explore all possible paths simultaneously, finding the most efficient route through quantum superposition. The energy exists in multiple locations at once, testing every pathway before collapsing into the optimal solution. Life has learned to use quantum mechanics as a navigation system for molecular energy transfer. Birds provide an even more remarkable example of biological quantum effects. Many species navigate during migration using Earth's magnetic field, but the mechanism remained mysterious until recently. Researchers have discovered that certain proteins in bird retinas contain pairs of electrons that become quantum entangled when exposed to light. These entangled electrons create a quantum compass that allows birds to literally see magnetic field lines as overlays on their visual perception. Think about the implications of this discovery. As you listen to these words, birds might be flying overhead with quantum entangled particles in their eyes, using the same spooky correlations that Einstein found so troubling as a practical tool for navigation. The boundary between quantum mechanics and everyday life dissolves when we look closely at the natural world. Recent research has even found evidence of quantum effects in human consciousness. Anesthesiologists have discovered that anesthetic drugs seem to disrupt quantum processes in neural microtubules, suggesting that consciousness might depend on quantum coherence in brain tissue. While this remains speculative and controversial, it opens the possibility that awareness itself involves quantum information processing. If consciousness does involve quantum effects, then the act of thinking might literally participate in the quantum nature of reality. Your thoughts right now might represent quantum information, processing that connects your awareness to the fundamental information structure of the universe. This remains unproven, but it emerges naturally from trusting quantum mechanics to extend into biological systems. As we push quantum mechanics to its limits, we're discovering that the act of measurement itself is far more subtle and powerful than anyone imagined. Recent experiments have achieved measurement precision that approaches the theoretical limits imposed by quantum mechanics, revealing new phenomena that exist at the boundary between the quantum and classical worlds. Quantum sensors based on entangled particles can measure magnetic fields with sensitivity that exceeds classical instruments by orders of magnitude. Gravitational wave detectors use quantum techniques to measure distortions in space-time smaller than 1,000th the width of a proton. Atomic clocks based on quantum transitions are so precise they would lose less than 1 second over the entire age of the universe. These advances in measurement capability are revealing aspects of reality that were previously hidden. Researchers have detected quantum effects in systems as large as mechanical oscillators visible to the naked eye. They've observed quantum superposition in objects containing trillions of atoms. The boundary between quantum and classical behavior is being pushed to scales where it intersects with our everyday experience. Consider what this means for our understanding of the relationship between observer and observed. As measurement becomes more precise and less invasive, we're discovering that the quantum world extends much further into the classical realm than anyone expected. The weird effects we thought were limited to individual particles now appear in systems we can see and touch directly. Recent experiments have achieved what physicists call quantum non-demolition measurements, observations that extract information about quantum systems without destroying their quantum properties. These measurements represent a new form of interaction with reality, one that allows us to peek into the quantum world without collapsing the very effects we're trying to observe. The development of quantum measurement techniques is also revealing new forms of quantum correlations that go beyond entanglement. Researchers have discovered quantum discord, quantum steering, and other non-classical relationships between particles that create information-sharing capabilities that classical systems cannot achieve. As you reflect on these discoveries, consider how they might relate to your own process of observation and awareness. Every moment, you're making countless measurements of your environment through your senses, extracting information that shapes your understanding of reality. While your sensory systems operate classically, they're interacting with a world that is fundamentally quantum mechanical at its deepest levels. As we stand at the threshold of a new era in our understanding of quantum mechanics, we're beginning to glimpse possibilities that were unimaginable. Just decades ago, quantum technologies are moving from laboratory curiosities to practical applications that could transform every aspect of human civilization. Quantum computers are beginning to solve problems that would take classical computers longer than the age of the universe. Quantum communication networks promise unbreakable security based on the fundamental laws of physics. Quantum sensors could detect dark matter, probe the structure of space-time, and reveal hidden dimensions of reality. But perhaps the most profound implications involve our understanding of consciousness, identity, and our place in the universe. If quantum mechanics truly extends into biological systems and potentially into consciousness itself, then we might be on the verge of discoveries that bridge the gap between mind and matter, between subjective experience and objective reality. Recent research in quantum artificial intelligence proposes that if machine consciousness emerges, it may involve quantum information processing. The boundary between human awareness and artificial intelligence could become blurred at the quantum level, creating new forms of consciousness that participate directly in the quantum nature of reality. These developments raise profound questions about the future of human experience. If we learn to harness quantum effects in our own neural systems, could we develop forms of awareness that transcend classical limitations? Could we achieve states of consciousness that access quantum information directly, creating new forms of intuition and understanding? While these possibilities remain highly speculative, they emerge naturally from trusting quantum mechanics to its logical conclusions. The theory that began with abstract mathematics describing atomic behavior has evolved into a framework that might ultimately explain consciousness, reality, and the deepest mysteries of existence itself. As you contemplate these possibilities, notice how they might already be manifesting in your own experience. The intuitive leaps of understanding, the sudden insights that seem to come from nowhere, the sense of connection to something larger than yourself. These experiences might reflect quantum information processing that operates below the threshold of classical awareness. Take a breath and allow yourself to rest in the mystery. The quantum world doesn't demand that we understand it completely or immediately. It invites us to remain open to possibilities that transcend our current categories of thought, to trust in a reality that is far stranger and more wonderful than we ever imagined. The journey through quantum mechanics reveals not just the nature of physical reality, but the nature of mystery itself. Every answer opens new questions. Every discovery reveals deeper puzzles. Every solution points toward greater mysteries waiting to be explored. In this vast quantum landscape, we are not separate observers studying an external world. We are participants in an ongoing conversation between consciousness and cosmos, between the known and the unknowable, between what is and what might be possible. The strange things that happen when we trust quantum mechanics completely aren't just scientific discoveries. They're invitations to expand our sense of what it means to exist in a universe that is infinitely creative, endlessly surprising, and fundamentally mysterious in the most beautiful possible way. Sweet dreams, and remember that in the quantum realm, even our dreams might be more real than we dare to imagine. Speaking of which, if these quantum mysteries have stirred something in your subconscious, you might be interested in exploring how these same principles might be speaking to you through the language of sleep itself in our previous episode. Quantum dreams, the hidden code your subconscious is desperate to reveal. Until we meet again in the endless mystery of quantum possibility, as we venture deeper into the implications of trusting quantum mechanics completely, we encounter perhaps its most personally transformative revelation, the dissolution of the boundaries we use to define ourselves. The quantum world doesn't just challenge our understanding of particles and forces. It questions the very nature of identity, individuality, and what it means to be a distinct entity in an interconnected universe. Consider for a moment the atoms that make up your body right now. Every carbon atom in your cells, every calcium atom in your bones was forged in the nuclear furnace of a star billions of years ago. These atoms have cycled through countless other forms before becoming temporarily organized into the pattern you call yourself. In a very real sense, you're made of ancient starlight, cosmic debris that has found a way to contemplate its own existence. But quantum mechanics reveals something even more profound about this cosmic recycling. The electrons in your atoms don't belong to you in any meaningful sense. They exist in probability clouds that extend beyond the classical boundaries of your body. The quantum fields that give rise to these particles permeate all of space, connecting you at the deepest level to every other structure in the universe. Recent experiments in quantum field theory have demonstrated that what we perceive as separate particles are actually localized excitations in universal fields. An electron in your brain is not fundamentally different from an electron in a distant star. They are both manifestations of the same underlying electron field, temporary patterns in a cosmic medium that knows no boundaries. This field-based view of reality suggests that individuality itself might be more of a temporary organizing principle than a fundamental property. You exist as a stable pattern in the universal quantum field, a localized concentration of information and energy that maintains its coherence for the brief span of a human lifetime. As you breathe right now, quantum fields are flowing through your body. Virtual particles are appearing and disappearing in the spaces between your cells. And the wave functions that describe your constituent particles are extending far beyond the boundaries of your skin. Where do you end and the rest of the universe begin? Quantum mechanics suggests that this question might not have a clear answer. Some interpretations of quantum mechanics go even further, proposing that consciousness itself might be a field phenomenon rather than a localized property of individual brains. While this remains highly speculative and lacks scientific consensus, it emerges naturally from applying quantum principles to the study of awareness and identity. Think about your own experience of consciousness right now. The sense of being a unified self, the feeling of existing as a continuous identity through time, the impression that your thoughts and experiences belong specifically to you. What if these subjective experiences reflect the same kind of pattern formation that creates particles from quantum fields? Your identity might be like a wave in the ocean of consciousness, a temporary formation that arises from deeper currents and will eventually merge back into the whole. This doesn't diminish the reality or importance of your individual experience. It places it within a larger context of universal interconnection and flow. One of the most intriguing frontiers emerging from quantum research involves the study of collective quantum phenomena, systems where individual components lose their separate identities and merge into unified quantum states. These discoveries hint at the possibility that consciousness itself might exhibit similar collective properties under certain conditions. In laboratories around the world, physicists have created what they call quantum condensates, states of matter where thousands or millions of particles merge into a single quantum entity. In these systems, individual particles lose their distinct identities and begin behaving as a unified whole, sharing the same quantum state and responding collectively to external influences. The most famous example is the Bose-Einstein condensate, a state of matter that occurs when atoms are cooled to temperatures just above absolute zero. At these extreme conditions, the quantum waves of individual atoms begin to overlap and synchronize, creating a single macroscopic quantum object that behaves like a giant atom made of thousands of smaller components. Recent experiments have pushed these collective quantum effects to unprecedented scales. Researchers have created condensates containing millions of atoms, quantum systems large enough to see with the naked eye that still exhibit the coherent behavior characteristic of individual quantum particles. These experiments demonstrate that quantum unity can emerge at scales that bridge the gap between microscopic and macroscopic reality. But perhaps the most intriguing aspect of these collective quantum phenomena involves their response to observation and measurement. When researchers probe these systems gently, they can maintain their collective coherence while extracting information about their quantum state. The systems seem to develop a kind of collective awareness that responds to observation in ways that individual particles cannot achieve. While we must be careful not to anthropomorphize these quantum systems or claim they possess consciousness in any human sense, their collective behavior does suggest that awareness and responsiveness might be more fundamental properties of quantum systems than previously thought. The boundary between observer and observed becomes blurred when the system being studied exhibits collective quantum coherence. As you consider these ideas, notice how they might relate to your own experiences of collective awareness. Have you ever been part of a group where individual perspectives seem to merge into a shared understanding? Moments in conversation, meditation, or creative collaboration, where the boundaries between separate minds seem to dissolve? While such experiences remain subjective and can't be directly compared to quantum condensates, they hint at the possibility that consciousness might be capable of collective states that transcend individual awareness. Some interpretations suggest that meditation traditions have long recognized and cultivated such states, using contemplative practices to access forms of awareness that mirror the collective coherence found in quantum systems. This remains highly speculative, but it points toward one of the most profound implications of trusting quantum mechanics completely. The possibility that consciousness itself might be capable of the same kind of collective unity that we observe in quantum condensates. We might have the capacity to temporarily transcend individual identity and participate in larger patterns of awareness that encompass multiple minds. Deep within the quantum realm lies a phenomenon that might illuminate one of humanity's most mysterious capabilities: the sudden emergence of creative insights and artistic inspiration. When we examine the quantum mechanical basis of neural activity, we discover processes that could provide a bridge between the deterministic world of classical physics and the seemingly magical realm of creative inspiration. Neural networks in the brain operate through electrochemical processes that involve the movement of ions across cell membranes and the release of neurotransmitter molecules at synaptic junctions. While these processes appear classical at first glance, recent research has revealed quantum effects operating at multiple scales within neural tissue microtubules. The structural elements that give neurons their shape exhibit quantum properties that persist even in the warm, noisy environment of the brain. These cellular components can maintain quantum coherence for surprisingly long periods, creating the possibility that quantum information processing contributes to neural computation in ways we're only beginning to understand. The implications for creativity are profound. Classical neural networks, whether in brains or computers, operate through predictable patterns of activation and response. While complex, their behavior is fundamentally deterministic, following logical pathways from input to output. Quantum processes, however, introduce genuine novelty through their inherent randomness and their ability to explore multiple possibilities simultaneously through superposition. Consider what happens during moments of creative breakthrough. An artist struggling with a composition suddenly perceives a solution that seems to arise from nowhere. A scientist working on a complex problem experiences an intuitive leap that bypasses logical analysis. A writer finds words arranging themselves in unexpected patterns that capture meanings they didn't know they were seeking. These experiences might reflect quantum processes in neural microtubules that allow consciousness to access information patterns not available through classical computation. While this remains speculative and unproven, quantum mechanics provides a framework for understanding how genuine novelty might emerge from the intersection of deterministic processes and quantum uncertainty. The quantum nature of creativity might also explain why inspiration often arises during states of relaxed awareness rather than focused concentration. Meditation, daydreaming, and the twilight states between waking and sleeping create neural conditions that might enhance quantum coherence in brain tissue, opening channels for information processing that transcend classical logic. As you reflect on your own creative experiences, consider whether they might involve quantum information processing that operates below the threshold of conscious awareness. The sudden insights, unexpected connections, and moments of artistic flow might represent your consciousness, accessing quantum computational resources that explore vast possibility spaces beyond the reach of classical thinking. This perspective doesn't diminish the role of training, practice, and conscious effort in creative work. Rather, it suggests that these classical elements create the conditions within which quantum processes can operate most effectively. The prepared mind becomes a quantum instrument capable of detecting subtle patterns and possibilities that exist in the space between certainty and chaos. One of the most mysterious aspects of consciousness involves our subjective experience of time, the flowing present moment that seems to move steadily from past to future, while maintaining a sense of continuity and coherence. Recent research in quantum mechanics has revealed temporal phenomena that might illuminate this fundamental aspect of awareness. Quantum systems exhibit what physicists call temporal correlations, relationships between quantum states that persist across time in ways that violate classical intuitions about causality. These correlations can create effects where the future appears to influence the past, not through dramatic time travel scenarios, but through subtle quantum connections that transcend ordinary temporal boundaries. In quantum systems, the concept of simultaneity becomes contextual rather than absolute. Events that appear simultaneous from one perspective might occur in sequence from another, and the order of cause and effect can depend on the observer's frame of reference. This temporal flexibility at the quantum level might provide clues about how consciousness creates its unique experience of temporal flow. Consider your own experience of the present moment, right now. You're aware of these words as they unfold in time, but you're also maintaining a sense of continuity that connects this moment to your memories of the past and your anticipations of the future. This creates what philosophers call the thick present, a temporal window that encompasses more than just the instantaneous now. Recent experiments in quantum biology have discovered that certain biological processes, including some that occur in neural tissue, exhibit quantum temporal correlations that could contribute to the brain's ability to integrate information across time. These findings remain preliminary and controversial, but they suggest that consciousness might involve quantum processes that create temporal coherence in ways classical physics cannot explain. The implications extend beyond individual consciousness to collective temporal experiences. Groups of people sometimes report shared experiences of temporal flow during meditation, ritual, or intense collaborative activities. While these reports remain subjective and difficult to study scientifically, they hint at the possibility that quantum temporal correlations might extend beyond individual brains to encompass multiple conscious systems. As you sit with these ideas, notice how your own experience of time might shift subtly. The flowing present that carries you from moment to moment might involve quantum processes that create continuity from discontinuous neural events, weaving the scattered firings of billions of neurons into the unified stream of consciousness you experience as temporal flow. This perspective doesn't solve the hard problem of consciousness or explain how subjective experience arises from neural activity, but it does suggest that the temporal dimension of awareness might involve quantum mechanical processes that operate according to rules more flexible and mysterious than classical physics allows. The quantum nature of temporal experience might also illuminate why certain contemplative practices seem to alter the subjective flow of time. Meditation, prayer, and other consciousness practices might tune the quantum processes that create temporal coherence, allowing practitioners to access states of awareness where the ordinary boundaries between past, present, and future become more fluid and permeable. While we must approach this topic with appropriate scientific caution, emerging research suggests that quantum coherence in biological systems might play a role in health, healing, and the body's capacity for self-repair. This doesn't mean quantum mechanics provides magical healing powers, but it does suggest that the quantum properties of living tissue might contribute to biological processes in ways we're only beginning to understand. The human body operates as an incredibly complex quantum system, with trillions of cells coordinating their activities through chemical signals, electrical impulses, and mechanical forces. Recent research has revealed that some of these biological processes maintain quantum coherence even in the warm, noisy environment of living tissue. Photosynthesis provides the clearest example of biological quantum effects contributing to enhanced efficiency. Plants use quantum superposition to explore multiple energy transfer pathways simultaneously, finding optimal routes for converting sunlight into chemical energy. This quantum enhancement allows photosynthesis to operate with near-perfect efficiency under a wide range of conditions. Similar quantum effects have been discovered in other biological systems, including enzyme reactions, cellular respiration, and DNA repair mechanisms. While research in this area remains preliminary, it suggests that life has evolved to harness quantum mechanical properties for enhanced biological function. The implications for human health remain speculative, but some researchers have proposed that disruptions in biological quantum coherence might contribute to certain disease processes. This could explain why some healing practices that seem to have no classical mechanism nevertheless show measurable effects in clinical studies. It's crucial to emphasize that this research doesn't validate claims about quantum healing or support the idea that consciousness can directly manipulate quantum states to cure disease. Such claims lack scientific support and can be dangerous when they discourage people from seeking appropriate medical care. However, the discovery of quantum effects in biological systems does suggest that the boundary between quantum and classical processes in living organisms is more complex than previously thought. This opens the possibility that some healing practices might work through mechanisms that involve quantum coherence in biological tissue, even if we don't yet understand how such mechanisms operate. As you breathe right now, quantum processes are occurring throughout your body, in the photosynthetic bacteria in your gut, in the electron transport chains in your mitochondria, in the enzymatic reactions that repair cellular damage and maintain biological function. These quantum effects operate automatically, without conscious control, as part of the body's natural healing and maintenance systems. The study of biological quantum effects might eventually lead to new approaches to medicine and healing that work with the body's natural quantum processes rather than against them. This could include therapies that enhance quantum coherence in biological systems, diagnostic techniques that measure quantum properties of living tissue, and treatments that support the body's quantum mechanical healing mechanisms. While such applications remain far in the future, they represent one of the most promising areas where trusting quantum mechanics completely might lead to practical benefits for human health and well-being. The quantum nature of life itself might hold keys to understanding and enhancing the body's remarkable capacity for self-repair and regeneration. As our understanding of quantum mechanics deepens and its implications for consciousness and reality become clearer, we find ourselves confronting profound ethical questions that emerge from the fundamental interconnectedness revealed by quantum theory. If we are truly entangled with the universe at the deepest level, what responsibilities does this create for how we live and interact with the world around us? The quantum principle of entanglement suggests that once systems have interacted, they remain connected in ways that transcend space and time. While this effect is most clearly demonstrated with individual particles, some interpretations suggest that it might extend to larger systems, including biological and possibly conscious systems. If consciousness involves quantum processes, as some researchers speculate, then the interactions between conscious beings might create subtle forms of entanglement that persist beyond the immediate context of encounter. Your conversations, relationships, and even casual interactions with other people might create quantum connections that influence both parties in ways too subtle for direct detection, but nevertheless real and significant. This possibility transforms our understanding of personal responsibility and social ethics. Rather than existing as isolated individuals whose actions affect others only through classical cause and effect, we might be participating in a web of quantum relationships where every interaction creates lasting connections and mutual influence. Consider how this might apply to your daily interactions with others. The quantum perspective symbolically suggests that kindness and compassion may reflect deeper forms of connection that extend beyond the immediate situation. Conversely, harm, hatred, and negative intention might create detrimental quantum relationships that persist in ways we don't fully understand. This doesn't mean that thoughts and emotions directly cause quantum effects in other people or in the external world. Such claims lack scientific support and can lead to victim blaming and magical thinking. Rather, it suggests that our actions and intentions might have consequences that extend through quantum relationships in ways that complement and enhance the classical mechanisms of social influence. The quantum perspective also raises questions about environmental ethics. If all matter is connected through quantum fields, and if consciousness involves quantum processes, then our relationship with the natural world might be more intimate and consequential than classical physics suggests. Damage to ecosystems might create quantum disruptions that affect human consciousness and well-being in ways we're only beginning to recognize. As you contemplate these possibilities, notice how they might influence your choices and behaviors. The quantum view of reality doesn't impose specific ethical obligations, but it does suggest that we exist within webs of connection and influence that extend far beyond what we can directly perceive or measure. This interconnected view of reality resonates with wisdom, traditions from around the world that have long recognized the fundamental unity underlying apparent separation. The quantum mechanical description of entanglement and field relationships provides a scientific framework that parallels these ancient insights about the interconnected nature of existence. The ethical implications of quantum mechanics remain speculative and unproven, but they offer a perspective that could enrich our understanding of moral responsibility and social relationship. If we are truly quantum beings living in a quantum universe, then every choice we make might ripple through the fabric of reality in ways we're only beginning to comprehend. As we approach the conclusion of our exploration into what happens when we trust quantum mechanics completely, we find ourselves standing at the threshold of possibilities that could fundamentally transform human experience and understanding. The convergence of quantum physics, neuroscience, and consciousness research is opening pathways toward new forms of awareness and capability that were unimaginable just decades ago. Current research in quantum biology continues to reveal quantum effects in an expanding range of biological systems. Scientists have discovered quantum coherence in photosynthesis, avian navigation, enzymatic reactions, and possibly even in neural microtubules. Each new discovery pushes the boundary between quantum and classical biology further into the realm of living systems. If consciousness does involve quantum information processing, as some researchers speculate, then we might be on the verge of developing technologies that can interface directly with these quantum aspects of awareness, brain-computer interfaces that operate through quantum rather than classical mechanisms could provide unprecedented access to the information processing capabilities of consciousness. Quantum computers are already demonstrating computational capabilities that transcend classical limitations by accessing quantum superposition and entanglement. If human consciousness involves similar quantum processes, then the boundary between artificial and biological intelligence might become blurred at the quantum level, creating hybrid systems that combine the best aspects of both approaches to information processing. The development of quantum sensing technologies is revealing previously hidden aspects of reality, from gravitational waves to dark matter. Similar advances in quantum measurement of biological systems might eventually allow us to detect and study the quantum aspects of consciousness directly, transforming our understanding of awareness from philosophical speculation to empirical science. These technological possibilities raise profound questions about the future evolution of human consciousness. If we learn to enhance or amplify the quantum processes that contribute to awareness, could we develop expanded forms of consciousness that transcend current human limitations? Could we access information processing capabilities that approach those of quantum computers while maintaining the subjective richness of conscious experience? Such possibilities remain highly speculative and far in the future, but they emerge naturally from trusting quantum mechanics to extend into the realm of consciousness and biology. The universe revealed by quantum theory is so much stranger and more capable than our classical intuitions suggest that almost any enhancement of human awareness seems possible given sufficient time and understanding. As you rest in contemplation of these possibilities, take a moment to appreciate the extraordinary nature of your current conscious experience. Right now, as you process these ideas and form your own understanding of their implications, you might be participating in quantum information processing that connects your awareness to the fundamental structure of reality itself. The thoughts arising in your mind, the insights that suddenly appear, the sense of understanding that emerges from confusion, all of these experiences might reflect quantum processes that operate at the intersection of consciousness and cosmos. You are not separate from the quantum reality we have been exploring. You are an expression of it, a temporary focal point where the universe develops the capacity to contemplate its own quantum nature. Whether or not consciousness ultimately proves to involve quantum mechanical processes, the journey of exploring these possibilities transforms our relationship with mystery, wonder, and the unknown. Quantum mechanics teaches us that reality is far stranger, more interconnected, and more creative than we ever dared imagine. The strange things that happen when we trust quantum mechanics completely aren't just scientific discoveries or technological possibilities. They are invitations to expand our sense of what it means to exist in a universe that transcends every boundary we thought was absolute, that connects every apparent separation, and that creates novelty and beauty through principles so subtle and profound that we've only begun to glimpse their implications. As we conclude this exploration, remember that the quantum world doesn't demand belief or understanding from us. It simply invites us to remain open to possibilities that exceed our current capacity to imagine. Every breath you take involves quantum processes. Every thought that arises might reflect quantum information processing. Every moment of awareness might participate in the universe's ongoing quantum evolution. Trust in the mystery, rest in the wonder, and know that you are part of something infinitely more magnificent than the classical world ever suggested. The quantum universe is not separate from you. It is expressing itself through you as you in every moment of your existence. Sweet dreams, and may your rest be filled with the gentle recognition that even in sleep, the quantum dance of consciousness continues, weaving your awareness into the eternal tapestry of possibility that surrounds and sustains all existence. And if these quantum explorations have stirred something deeper in your subconscious mind, you might find yourself drawn to our previous journey into how these same mysterious principles speak to you through the language of dreams, in Quantum Dreams. The hidden code. Your subconscious is desperate to reveal. Until we meet again in the endless mystery of quantum possibility, rest well in the knowledge that you are both observer and participant in the most beautiful experiment the universe has ever conducted. The emergence of consciousness from quantum fields, awareness from uncertainty, and meaning from the dance of infinite possibility. In laboratories across the world, something peculiar happens whenever scientists try to measure quantum systems with perfect precision. The more carefully they observe, the more the system seems to resist their gaze, as if reality itself prefers to remain slightly blurred around the edges. This isn't a limitation of their instruments or a flaw in their methodology. It's a fundamental feature of quantum mechanics that reveals something profound about the relationship between attention and reality. The uncertainty principle, discovered by Werner Heisenberg, tells us that certain pairs of properties cannot be measured simultaneously with perfect accuracy. The more precisely you know a particle's position, the less precisely you can know its momentum, and vice versa. This isn't because our tools are crude or our methods inadequate. It's because nature itself operates according to principles that maintain irreducible uncertainty at the deepest levels of reality. Consider what this might mean for your own experience of attention and awareness. When you focus intensely on one aspect of your experience, other aspects naturally fade into the background. The sharper your concentration becomes on any single element, the more peripheral your awareness of everything else. This parallel between quantum uncertainty and conscious attention remains metaphorical rather than literal, but it suggests that indeterminacy might be a fundamental feature of information processing systems, whether they involve particles or thoughts. Recent experiments have pushed the boundaries of quantum measurement in remarkable directions. Researchers have developed techniques called weak measurements that extract information about quantum systems without fully collapsing their wave functions. These gentle observations reveal hidden aspects of quantum reality that stronger measurements would destroy, like whispering questions to a shy animal that would flee if approached too directly. The implications extend beyond technical physics into the realm of contemplative practice and mindful awareness. Traditional meditation techniques often emphasize the importance of gentle attention, observing the mind without grasping or forcing. This soft approach to awareness mirrors the quantum measurement strategies that preserve delicate quantum states while still extracting meaningful information. As you sit with these ideas right now, notice how your own attention operates. Are you grasping at these concepts, trying to pin them down with analytical precision, or can you hold them lightly, allowing understanding to emerge without forcing comprehension? The quantum world suggests that some forms of knowledge might require gentle approaches that honour the mystery rather than demanding complete clarity. The observer effect in quantum mechanics has been misunderstood and misrepresented in popular culture, often leading to claims that consciousness directly creates reality through observation. While these dramatic interpretations lack scientific support, the actual observer effect does reveal something subtle and important about the relationship between information extraction and system disturbance. Every measurement involves an interaction between the measuring device and the system being measured. In classical physics, we can make this interaction arbitrarily small, approaching the ideal of pure observation without influence. But quantum mechanics reveals fundamental limits to how gently we can probe reality. Every act of measurement necessarily disturbs what it seeks to observe, creating an unavoidable intimacy between observer and observed. This intimate relationship between measurement and disturbance has philosophical implications that extend beyond physics. It suggests that pure objectivity, the dream of observing reality without influencing it, might be impossible even in principle. Every attempt to know the world necessarily changes it in some small way, creating a participatory universe where knowledge emerges through relationship rather than detached observation. Think about how this principle might apply to self-knowledge and introspection. The very act of observing your own thoughts and emotions influences them, creating feedback loops between awareness and experience. You cannot step outside yourself to observe your mind with perfect objectivity because the observer and the observed are part of the same system. This doesn't invalidate self-reflection, but it does suggest that genuine self-knowledge requires accepting the participatory nature of introspection. Deep within the quantum realm exists a phenomenon so counterintuitive that it seems to violate the most basic laws of physics. Particles regularly pass through energy barriers that classical mechanics says should be impenetrable, appearing on the other side without ever having the energy to climb over the top. This effect, called quantum tunneling, enables the nuclear fusion that powers stars, the operation of modern electronics, and possibly even some of the most mysterious aspects of consciousness and creativity. Imagine rolling a ball toward a hill that's too high for the ball's energy to carry it over the top. In the classical world, the ball would simply roll back down, but in the quantum world, there's a small probability that the ball would simply appear on the other side of the hill, having tunneled through the barrier without ever climbing over it. This isn't magic or science fiction, it's a measurable, predictable phenomenon that occurs billions of times per second in the devices that power our modern world. Quantum tunneling works because particles don't have definite positions until they're measured. Instead, they exist as probability waves that can extend beyond classical boundaries. Even when most of the wave is blocked by a barrier, a small portion can extend through to the other side. When a measurement occurs, there's a chance the particle will be found in this extended region, having effectively tunneled through the obstacle. The implications of tunneling extend far beyond particle physics into the realm of human experience and possibility. While we must be careful not to overextend quantum analogies into areas where they don't apply, the principle of tunneling does offer a compelling metaphor for understanding breakthrough experiences in creativity, learning, and personal development. Consider those moments when solutions to complex problems seem to arise from nowhere, bypassing the logical steps you expected to follow. An artist struggling with a creative block suddenly perceives a new direction that wasn't accessible through conventional approaches. A student grappling with a difficult concept experiences a sudden shift in understanding that seems to tunnel through confusion directly to clarity. While these experiences don't involve literal quantum tunneling, they might reflect information processing strategies in the brain that explore multiple possibilities simultaneously, finding pathways through conceptual barriers that linear thinking cannot navigate. Some research suggests that creative insights involve neural processes that access remote associations and unexpected connections, tunneling through the usual constraints of logical reasoning. Recent studies of problem solving in both humans and artificial intelligence systems have revealed that breakthrough solutions often emerge through processes that explore vast possibility spaces in ways that don't follow predictable paths. These systems seem to develop the capacity to tunnel through conventional limitations, finding solutions that exist on the other side of apparent impossibilities. As you reflect on your own experiences of breakthrough and insight, consider whether they might involve mental processes that parallel quantum tunneling in their ability to transcend apparent barriers. This remains a speculative connection rather than a proven scientific fact, but it offers a framework for understanding how genuine novelty might emerge from consciousness. The quantum tunneling effect also reveals something profound about the nature of possibility itself. In the quantum world, barriers are never absolute. There's always some probability, however small, that particles will find ways through or around obstacles that seem impermeable. This suggests that impossibility might be more of a practical limitation than a fundamental law of nature. Think about the barriers in your own life that seem insurmountable. The quantum perspective doesn't promise that positive thinking will magically dissolve these obstacles, but it does suggest that reality contains more flexibility and potential for unexpected breakthrough than classical physics would predict. Sometimes the most direct path forward involves finding ways around or through barriers rather than trying to overcome them through brute force. Perhaps no aspect of quantum mechanics captures the imagination quite like superposition, the principle that quantum systems can exist in multiple states simultaneously until the moment of measurement. An electron can spin up and down at the same time. A photon can travel through multiple paths simultaneously. A quantum particle can be in several locations at once, existing as a shimmering cloud of possibility rather than a definite entity with fixed properties. This quantum multiplicity challenges our most basic assumptions about the nature of existence and identity. In our everyday experience, things are either one way or another. A door is open or closed. A light is on or off. A person is here or there. But the quantum world reveals that this either-or logic might be a limitation of our macroscopic perspective rather than a fundamental law of reality. Recent experiments have demonstrated quantum superposition in increasingly large and complex systems. Researchers have created superposition states in molecules containing thousands of atoms, in mechanical oscillators visible to the naked eye, and in superconducting circuits that operate at scales approaching everyday technology. Each new demonstration pushes the boundary between quantum and classical behavior further into the realm of direct human experience. The implications of superposition extend beyond technical physics into questions of identity, potential, and the nature of becoming. While we must be careful not to apply quantum principles literally to macroscopic systems like human consciousness, the concept of superposition does offer a compelling framework for understanding the multiplicity that characterizes subjective experience. Consider your own sense of identity right now. Are you a single fixed self, or do you contain multiple potential selves that coexist within your awareness? Different aspects of your personality emerge in different contexts. Different skills and capabilities lie dormant until circumstances call them forth. Different possible futures seem equally real and compelling until choices collapse them into single outcomes. This multiplicity of being isn't a flaw or confusion in human identity. It might be a reflection of the fundamental quantum nature of reality itself. While your macroscopic body doesn't exist in quantum superposition, the information processing that gives rise to consciousness might involve quantum effects that preserve multiple possibilities until specific contexts require definite responses. Some interpretations of consciousness research suggest that awareness involves the continuous collapse of mental superpositions as attention selects specific contents from vast fields of possibility. Each moment of focused attention might represent a kind of measurement that collapses the superposition of potential thoughts, perceptions, and responses into specific conscious experiences. As you listen to these words right now, notice how your mind contains multiple streams of potential response. You might feel curious about these ideas while simultaneously skeptical about their implications. You might experience understanding and confusion as overlapping rather than mutually exclusive states. This cognitive multiplicity might reflect quantum superposition effects in the neural processes that support consciousness. The quantum principle of superposition also illuminates the nature of potential and actualization in human development. Rather than thinking of your capabilities as fixed properties that you either possess or lack, consider them as existing in superposition states that can be collapsed into manifestation through appropriate conditions and choices. Your creative potential, your capacity for compassion, your ability to learn and grow, these might exist as quantum superpositions of possibility that await the right circumstances to collapse into actual expression. This perspective transforms personal development from a process of acquiring new properties to one of learning to collapse existing superpositions in ways that serve your highest aspirations. One of the most profound mysteries in quantum mechanics involves understanding how the strange, probabilistic quantum world gives rise to the familiar, deterministic reality we experience in our daily lives. This transformation occurs through a process called decoherence, where quantum superpositions gradually lose their coherence through interaction with the environment, creating the appearance of classical behavior without actually destroying the underlying quantum nature of reality. Decoherence provides a bridge between the quantum and classical worlds, explaining why we don't observe cats that are simultaneously alive and dead, or tables that exist in multiple locations at once. It's not that quantum effects disappear at larger scales, but rather that they become so entangled with their environment that their quantum properties become effectively invisible, masked by the complexity of their interactions. Imagine a quantum system as a delicate musical performance that requires perfect coordination between multiple instruments. In isolation, this quantum orchestra can maintain precise harmonies and complex rhythms that create beautiful, coherent music. But as the environment intrudes, adding noise and interference, the delicate coordination breaks down. The individual instruments continue playing, but their collective coherence dissolves into what sounds like random noise. This analogy illustrates how decoherence works in quantum systems. The quantum properties don't disappear, but they become so scrambled by environmental interactions that they can no longer produce observable quantum effects. The system appears classical, not because it has lost its quantum nature, but because that nature has become hidden beneath layers of environmental entanglement. Recent research has revealed that decoherence occurs much more rapidly than originally expected, especially in warm, noisy biological systems. This discovery initially seemed to rule out quantum effects in living organisms, but subsequent experiments have shown that biological systems have evolved sophisticated mechanisms to protect quantum coherence in specific contexts where it provides functional advantages. The implications of decoherence extend beyond physics into questions about the relationship between inner experience and outer expression. Consider how your rich inner world of thoughts, emotions, and possibilities gets translated into specific words and actions as you interact with others. This process might parallel decoherence, where the full quantum superposition of your mental states collapses into specific classical expressions through social interaction. Think about a moment when you were trying to communicate a complex idea or deep emotion to another person. The fullness of your inner experience existed in a kind of superposition of multiple possible expressions. But the act of speaking or writing forced you to collapse this multiplicity into specific words and gestures. The decoherence of expression necessarily reduced the richness of inner experience, but it also made communication possible. As you reflect on this process right now, notice how your understanding of these ideas exists in a kind of superposition state, containing multiple interpretations and applications that coexist until specific contexts or questions force them to collapse into definite responses. This cognitive decoherence allows you to navigate the complexity of conceptual understanding while still maintaining access to the full richness of possibility. Decoherence also offers insights into the nature of memory and the persistence of experience. Memories don't exist as fixed recordings of past events, but rather as quantum information patterns that undergo continuous decoherence and recoherence as they interact with new experiences and contexts. Each time you recall a memory, you're not simply playing back a classical recording, but rather collapsing a quantum superposition of possible reconstructions into a specific remembered experience. This perspective transforms our understanding of personal history and identity. Rather than being determined by fixed past events, your sense of self emerges from the ongoing decoherence of quantum memory patterns that contain multiple versions of your personal story. This doesn't mean that memories are arbitrary or that personal history is meaningless, but it does suggest that identity is more fluid and creative than classical models would predict. Beneath the apparent solidity of matter lies a deeper reality that quantum field theory reveals to be far stranger and more musical than our everyday experience suggests. Every particle in the universe, from the electrons in your atoms to the photons carrying these words to your eyes, represents a localized vibration in universal fields that permeate all of space and time. These quantum fields are not things in space, but rather the fundamental medium from which space itself emerges. They exist in a state of constant activity, even in what we call empty vacuum, creating and annihilating virtual particles in a ceaseless dance of possibility and actualization. The entire universe can be understood as a vast symphony of quantum field vibrations, with particles as temporary notes in an eternal cosmic composition. Consider the profound implications of this field-based view of reality. The electrons in your brain that enable thought, the photons that carry light from distant stars, the quarks that form the protons in your DNA, all of these are expressions of the same underlying quantum fields. At the deepest level, there is no separation between you and the rest of the universe. You are localized patterns in fields that extend throughout all of space and time. Recent advances in quantum field theory have revealed even stranger possibilities. Researchers have discovered that quantum fields can exist in states that have no classical analogue, creating forms of matter and energy that transcend our ordinary categories of understanding. These exotic field configurations challenge our most basic assumptions about the nature of substance and form. Some interpretations suggest that consciousness itself might emerge from specific patterns of quantum field activity, particularly in the complex electromagnetic fields generated by neural networks in the brain. While this remains highly speculative and lacks scientific consensus, it offers a framework for understanding how subjective experience might arise from objective physical processes. Think about your own experience of consciousness right now as you process these ideas. The sense of unified awareness that integrates sensory information, memories, and conceptual understanding into a coherent stream of experience might reflect quantum field patterns that create temporary stability in the midst of constant flux and change. As you breathe, quantum fields are flowing through your body. Virtual particles are appearing and disappearing in the spaces between your cells, and the boundary between your individual existence and the universal field structure becomes increasingly difficult to define. You are not separate from these fields. You are a temporary organization of their activity, a local intensification of the cosmic symphony. The musical metaphor for quantum fields extends beyond mere analogy into mathematical reality. The equations that describe quantum field behavior are formally similar to those that describe wave propagation and harmonic oscillation. In a very real sense, the universe operates according to principles of resonance, interference, and harmonic relationship that mirror musical composition. This perspective transforms our understanding of beauty and aesthetic experience. When you're moved by music, inspired by art, or touched by natural beauty, you might be responding to patterns that reflect the fundamental harmonic structure of quantum field reality. Aesthetic experience could be consciousness recognizing and resonating with the musical patterns that constitute the deepest level of physical existence. Recent experiments in quantum acoustics have demonstrated that sound waves can exhibit quantum properties under specific conditions, creating acoustic analogues of quantum phenomena like entanglement and superposition. These discoveries blur the boundary between the metaphorical and literal aspects of describing the universe as fundamentally musical in nature. Take a moment to listen to the subtle sounds around you right now, the ambient noise of your environment, the rhythm of your breathing, the quiet hum of electronic devices. All of these acoustic patterns exist within the larger symphony of quantum field vibrations that constitute physical reality. You are both listener and instrument in this cosmic composition, both audience and performer in the ongoing music of existence. As we explore the implications of trusting quantum mechanics completely, we encounter one of the most profound questions in all of science. Why does the universe seem so precisely calibrated to allow for the emergence of complexity, life, and consciousness? This question leads us into the territory of the anthropic principle, the observation that the fundamental constants of nature fall within the narrow ranges necessary for the existence of stable matter, chemical complexity, and biological evolution. The anthropic principle comes in several versions, from the weak anthropic principle that simply notes we observe a universe compatible with our existence, to the strong anthropic principle that suggests the universe might be designed or selected for the emergence of conscious observers. While these ideas venture into philosophy and cosmology rather than established physics, they emerge naturally from quantum mechanical considerations about the role of observation in determining reality. Consider the remarkable fine-tuning that characterizes our universe. If the strength of gravity were slightly different, stars couldn't form stable nuclear reactions. If the electromagnetic force had a different value, atoms couldn't hold together to create chemistry. If the expansion rate of space were altered by even tiny amounts, the universe would either collapse immediately or expand so rapidly that no structures could form. These observations don't prove that consciousness plays a fundamental role in shaping physical laws, but they do suggest that observers and observed might be more intimately connected than classical physics assumed. Some interpretations of quantum mechanics propose that consciousness doesn't just observe reality, but participates in its ongoing creation through the collapse of quantum superpositions. While such participatory interpretations remain speculative and controversial, they align with certain contemplative traditions that have long recognized the intimate relationship between awareness and reality. These traditions suggest that consciousness isn't separate from the world it observes, but rather represents the universe's capacity to know and experience itself. As you contemplate these ideas, notice how they might influence your sense of relationship with the cosmos. Rather than existing as an isolated observer in an indifferent universe, you might be a focal point where cosmic evolution achieves self-awareness, a temporary intensification of the universe's capacity for experience and understanding. This participatory view doesn't mean that individual consciousness creates reality through wishful thinking or positive visualization. Such claims lack scientific support and can lead to harmful forms of spiritual materialism and victim blaming. Rather, it suggests that consciousness might be woven into the fabric of reality at such a fundamental level that the distinction between observer and observed becomes meaningless. Recent research in quantum biology has revealed that life actively exploits quantum mechanical effects for enhanced efficiency and capability. This suggests that biological evolution might have discovered ways to harness quantum phenomena, creating increasingly sophisticated forms of quantum information processing that culminate in conscious awareness. If consciousness does involve quantum information processing, then every moment of aware experience might represent a form of cosmic self-measurement, a way the universe observes and influences its own quantum evolution. This perspective transforms personal consciousness from an accident of biological complexity into an essential aspect of cosmic development. Think about your own experience of making choices and setting intentions. While individual decisions don't directly manipulate quantum fields or collapse wave functions on a cosmic scale, they do represent ways that consciousness participates in shaping the unfolding of possibility into actuality. Through choices, attention, and intention, conscious beings might serve as agents of cosmic creativity and evolution. At the deepest level, quantum mechanics suggests that reality might be fundamentally informational rather than material. This perspective, emerging from research in quantum computing and information theory, proposes that matter and energy are expressions of underlying information patterns rather than the other way around. If this view is correct, then the universe operates more like a vast quantum computer than a mechanical clockwork, processing information rather than simply moving objects through space. The quantum information perspective emerged from studies of black holes and the limits of information storage in physical systems. Researchers discovered that the maximum amount of information that can be contained in any region of space depends not on its volume, but on the area of its boundary. This holographic principle suggests that three-dimensional reality might be a projection from information encoded on two-dimensional surfaces. Recent advances in quantum computing have demonstrated information processing capabilities that transcend classical limitations by exploiting quantum superposition and entanglement. Quantum computers don't just process information faster, they access information relationships that don't exist in classical systems, suggesting that information itself has quantum properties that classical physics cannot describe. Consider what this might mean for consciousness and subjective experience. If reality is fundamentally informational, then awareness might represent a particular form of quantum information processing rather than an emergent property of material brain activity. Consciousness could be the universe's way of processing information about itself, creating subjective experience as a byproduct of cosmic computation. While this information-theoretic view of consciousness remains highly speculative and lacks scientific consensus, it offers a framework for understanding some of the most puzzling aspects of awareness. The unity of conscious experience, the integration of multiple sensory inputs into coherent perceptions, the binding of memories and anticipations into continuous personal narratives. These features of consciousness might reflect quantum information processing that creates coherence from distributed neural activity. As you process these ideas right now, notice how your understanding emerges from the integration of multiple information streams. Visual information from these words combines with auditory information, if you're listening, conceptual information from memory, and emotional information from your responses to create a unified conscious experience that transcends the sum of its components. This information integration might involve quantum processes that create correlations between different brain regions, binding distributed neural activities into coherent conscious states. While direct evidence for quantum information processing in consciousness remains limited, the informational view provides a promising direction for understanding how subjective experience arises from objective neural activity. The quantum information perspective also transforms our understanding of memory, learning, and knowledge. Rather than storing information in fixed locations like books in a library, quantum systems can store information in correlations between particles that exist across space and time. Quantum memories are distributed, non-local, and capable of existing in superposition states that contain multiple versions of stored information simultaneously. Think about your own memories and how they seem to exist, not as fixed recordings, but as reconstructive processes that create different versions of past events depending on present contexts and concerns. This reconstructive quality of memory might reflect quantum information storage that maintains multiple possible versions of past experiences in superposition until specific contexts collapse them into particular remembered experiences. The informational view of reality also illuminates the relationship between knowledge and being. If consciousness involves quantum information processing, then learning isn't just acquiring new data, but rather developing new patterns of quantum correlation that connect awareness to deeper aspects of reality. Understanding becomes a form of quantum entanglement between knower and known. The relationship between quantum mechanics and free will represents one of the most perplexing intersections of physics and philosophy. Classical determinism seemed to leave no room for genuine choice, suggesting that all future events were fixed by past conditions and natural laws. Quantum mechanics introduces fundamental randomness into physical processes, but random events seem no more freely chosen than determined ones. Yet some interpretations suggest that consciousness might participate in quantum measurement processes in ways that create genuine agency and choice. The challenge of understanding free will in a quantum context requires distinguishing between different types of causation and different levels of description. While quantum events exhibit fundamental randomness at the microscopic scale, the emergence of classical behavior through decoherence creates predictable patterns at larger scales. Consciousness might operate at intermediate scales, where quantum effects are neither completely random nor fully determined, creating space for genuine agency. Consider your own experience of making choices right now. When you decide to continue listening or to pause and reflect, this decision doesn't feel either completely determined by prior causes or entirely random. It feels like a genuine choice emerging from your consideration of possibilities, influenced by but not completely controlled by past experiences, preferences, and circumstances. Some interpretations of quantum mechanics suggest that conscious observation plays a special role in collapsing quantum superpositions, selecting specific outcomes from multiple possibilities. While this observer effect doesn't require consciousness in most physical contexts, it's possible that biological systems have evolved to exploit quantum indeterminacy in ways that create genuine choice and agency. Recent research in neuroscience has identified neural processes that seem to involve quantum effects, particularly in the microtubules that provide structural support for neurons. While the functional significance of these quantum processes remains unclear, they suggest that consciousness might involve quantum information processing that operates according to principles and more flexible than classical computation. Think about the subtle process of decision-making as it unfolds in your awareness right now. Complex considerations seem to be weighed simultaneously. Multiple possibilities coexist until the moment of choice, and decisions often emerge through processes that feel more like recognition than calculation. This phenomenology of choice might reflect quantum processes that explore possibility spaces before collapsing into specific outcomes. The quantum perspective on free will doesn't resolve all philosophical questions about moral responsibility and personal agency, but it does suggest that consciousness operates in a universe where genuine novelty and creativity are possible. Rather than being either completely determined or entirely random, conscious choice might emerge from the intersection of quantum indeterminacy and classical structure, creating agency through the collapse of possibility into actuality. As you contemplate these ideas about choice and agency, notice how your own sense of freedom might be enhanced rather than diminished by understanding consciousness as a quantum phenomenon. If awareness participates in the fundamental creativity of the universe through quantum measurement processes, then every genuine choice becomes a way of participating in cosmic evolution and development. This participatory view of free will carries both empowerment and responsibility. While individual consciousness doesn't control quantum events through wishful thinking, conscious choice might serve as channels of cosmic creativity, participating in the universe's ongoing evolution through the choices we make and the intentions we set. In the depths of space, two particles separated by billions of light years maintain a connection so intimate that measuring one instantly affects the other, defying every intuition we have about the nature of separation and distance. This phenomenon, quantum entanglement, represents perhaps the most profound challenge to our classical understanding of reality, suggesting that the universe operates according to principles of connection that transcend the boundaries of space and time. Einstein famously called entanglement spooky action at a distance, and his discomfort with the phenomenon led him to propose that quantum mechanics must be incomplete, hiding unknown variables that would restore local causality to physics. But decades of increasingly sophisticated experiments have confirmed that entanglement is real, that particles can maintain correlations that no classical theory can explain, and that the universe is fundamentally non-local at its deepest level. Recent experiments have pushed entanglement to unprecedented scales, and distances researchers have created entangled states involving thousands of particles, demonstrated entanglement between Earth and satellites in orbit, and maintained quantum correlations across continental distances using fiber optic networks. Each new demonstration reveals that the spookiness Einstein found so troubling is not a limitation of our understanding, but a fundamental feature of reality itself. The implications of entanglement extend far beyond technical physics into questions about the nature of relationship, connection, and the possibility of genuine intimacy in a vast and seemingly indifferent universe. If particles can maintain instantaneous correlations across cosmic distances, what might this suggest about the potential for connection between conscious beings? While we must be careful not to overextend quantum mechanical principles into areas where they don't apply, entanglement does provide a scientific framework for understanding how separation might be less fundamental than connection in the deeper structure of reality. Some speculative interpretations suggest that consciousness itself might involve entanglement-like correlations between different brain regions, or even between different conscious systems. As you sit with these ideas, take a moment to reflect on your own experiences of deep connection with others. Have there been moments when you felt so attuned to another person that boundaries seemed to dissolve, when communication occurred through channels that transcended ordinary language? While such experiences don't involve literal quantum entanglement, they might reflect information-sharing processes that mirror the non-local correlations found in quantum systems. The study of entanglement has also revealed that quantum correlations can exist in different forms and degrees. Some entangled states exhibit perfect correlations, where measuring one particle completely determines the state of its partner. Others show partial entanglement, where correlations exist but allow for individual variation and independence. This spectrum of quantum connection might provide insights into the different types and depths of relationship possible between conscious beings. Consider how your own relationships exist along a similar spectrum of connection and independence. Some relationships involve deep attunement and mutual influence, while others maintain connection, while preserving individual autonomy. The quantum perspective doesn't explain these relational dynamics directly, but it does suggest that connection and separation might be complementary aspects of a deeper reality rather than mutually exclusive possibilities. Recent research in quantum biology has discovered entanglement-like effects in certain biological systems, particularly in photosynthetic processes and possibly in neural microtubules. While these findings remain preliminary and controversial, they suggest that life might have evolved mechanisms to exploit quantum correlations for enhanced efficiency and coordination. If biological systems can maintain quantum entanglement under warm, noisy conditions, then the boundary between quantum and classical biology becomes more complex and interesting than previously thought. This opens possibilities for understanding biological coordination and information sharing that transcend classical biochemical mechanisms. At the intersection of quantum physics and consciousness, research lies one of the most profound mysteries in all of science. How does subjective experience arise from objective physical processes? This question, known as the hard problem of consciousness, has puzzled philosophers and scientists for centuries, and quantum mechanics might provide new perspectives on this ancient puzzle. The hard problem isn't about explaining the functions of consciousness, such as attention, memory, or information processing. Neuroscience has made remarkable progress in understanding these cognitive capabilities and their neural correlates. The hard problem concerns the qualitative, subjective nature of experience itself, the felt sense of what it's like to be conscious. When you see the color red, neural processes in your visual system respond to specific wavelengths of light. But why should these physical processes be accompanied by the subjective experience of redness? When you feel sad, chemical and electrical changes occur in your brain. But why should these changes create the felt quality of sadness, rather than simply processing information about loss or disappointment? Classical physics struggles with this problem because it describes the world in terms of objective, measurable properties that seem fundamentally different from subjective, qualitative experience. But quantum mechanics introduces elements that might bridge this explanatory gap, particularly the role of observation in determining reality and the possibility that consciousness participates in quantum measurement processes. Some interpretations of quantum mechanics propose that consciousness plays a special role in collapsing quantum superpositions, selecting specific outcomes from multiple possibilities through the act of observation. While this remains speculative and controversial, it suggests that awareness might be woven into the fabric of physical reality rather than emerging from it as a secondary phenomenon. Recent research by physicists like Roger Penrose and Stuart Hameroff has proposed that consciousness involves quantum processes occurring in cellular structures called microtubules within brain neurons. According to their theory, these quantum processes create the unity and qualitative nature of conscious experience through quantum coherence effects that classical neural networks cannot achieve. While the Penrose-Hameroff theory remains unproven and faces significant skepticism from mainstream neuroscience, it represents a serious attempt to ground consciousness in quantum mechanical principles. Other researchers have proposed alternative quantum theories of consciousness that focus on different aspects of neural activity or different quantum phenomena. As you reflect on your own conscious experience right now, notice the immediate, qualitative nature of awareness itself, the sense of being present, the felt quality of understanding these ideas, the subjective experience of curiosity or wonder. These aspects of consciousness seem to transcend the objective, measurable properties that classical physics can describe. The quantum perspective doesn't solve the hard problem of consciousness, but it does provide conceptual resources that might eventually contribute to a solution. If consciousness involves quantum information processing, then subjective experience might represent the intrinsic, qualitative aspect of quantum measurement processes that occur in neural tissue. This remains highly speculative, but it suggests that the qualities of conscious experience might not be separate from physical processes, but rather represent the intrinsic nature of certain types of quantum information processing. Just as particles have both wave and particle aspects, depending on how they are observed, neural processes might have both objective and subjective aspects, depending on whether they're viewed from external or internal perspectives. Think about how this possibility might transform your understanding of your own consciousness. Rather than being a mysterious addition to physical brain activity, your subjective experience might represent the intrinsic nature of quantum information processing that occurs when neural networks achieve specific types of coherence and integration. Time, perhaps more than any other aspect of reality, reveals its quantum nature through the mysterious workings of memory and the subjective experience of temporal flow. While classical physics treats time as a uniform background against which events unfold, quantum mechanics reveals temporal relationships that are contextual, relative, and deeply connected to the processes of observation and measurement. In the quantum world, the sequence of cause and effect can become ambiguous, with future measurements appearing to influence past events through phenomena like quantum retrocausality. While these effects don't allow for dramatic time travel scenarios, they do suggest that temporal relationships in quantum systems are more flexible and context-dependent than our everyday experience suggests. Consider how this quantum flexibility of time might relate to your own experience of memory and temporal consciousness. Memories don't exist as fixed recordings of past events, but rather as reconstructive processes that create different versions of past experiences depending on present contexts and concerns. Each time you remember an event, you're not simply retrieving stored information, but rather collapsing a superposition of possible reconstructions into a specific, remembered experience. Recent research in neuroscience has revealed that memory formation and recall involve complex processes of reconstruction rather than simple recording and playback. Memories are influenced by present emotions, subsequent experiences, and current understanding in ways that create dynamic, evolving narratives rather than static historical records. This reconstructive quality of memory might reflect quantum information storage processes that maintain multiple versions of past experiences in superposition until specific contexts collapse them into particular remembered experiences. While this remains speculative, it provides a framework for understanding why memory is so creative, flexible, and context-dependent. The quantum perspective on time also illuminates the nature of anticipation and future planning. Just as memories exist as reconstructive processes rather than fixed records, anticipations might exist as superpositions of possible futures that collapse into specific expectations through the influence of present circumstances and choices. As you contemplate your own future right now, notice how multiple possibilities seem to coexist in your awareness simultaneously. Different potential outcomes feel equally real and compelling until specific choices or circumstances collapse them into single, anticipated trajectories. This temporal superposition of possibilities might reflect quantum processes in consciousness that maintain multiple future scenarios until decision-making processes select specific paths. The experience of the present moment itself reveals quantum-like properties in its thickness and complexity. The now that you're experiencing isn't a mathematical point between past and future, but rather a rich extended window that integrates recent memories, immediate sensations, and anticipated outcomes into a coherent conscious experience. This thick present might reflect quantum coherence processes in neural networks that bind information across temporal scales, creating the unified stream of consciousness that integrates past experience, present awareness, and future anticipation into seamless subjective flow. While direct evidence for quantum temporal integration in consciousness remains limited, the quantum perspective provides conceptual tools for understanding how consciousness creates temporal continuity from discrete neural events. Take a breath and notice the temporal complexity of your present experience right now. The words you're hearing carry meanings that connect to past understanding, while opening possibilities for future insight. Your awareness integrates multiple temporal scales simultaneously, from the immediate flow of auditory information to the longer-term development of conceptual understanding. In the intersection between quantum mechanics and biological systems lies a phenomenon that challenges our understanding of healing, recovery, and the relationship between mind and body. The placebo effect, long dismissed as a mere nuisance in medical research, might actually reveal quantum-like processes in biological systems that blur the boundary between expectation and physical reality. Recent research has revealed that placebo responses can produce measurable changes in brain chemistry, immune function, and even genetic expression. These effects occur not just through psychological mechanisms, but through complex interactions between nervous, endocrine, and immune systems that create genuine physiological changes in response to expectation and belief. While we must be extremely careful not to overstate these findings or suggest that consciousness directly manipulates quantum states to cure disease, the placebo effect does demonstrate that the boundary between subjective experience and objective biology is more permeable than classical medicine typically assumes. Some researchers have proposed that placebo responses might involve quantum coherence effects in biological systems, particularly in the microtubules that provide structural support for cells throughout the body. These speculative theories suggest that expectation and intention might influence quantum processes in cellular structures, leading to cascading changes in biological function. It's crucial to emphasize that these ideas remain unproven and should never be used to replace appropriate medical care. Claims about quantum healing often lack scientific support and can be dangerous when they discourage people from seeking effective treatment for serious medical conditions. However, the genuine placebo effect does suggest that consciousness and biology interact in ways that classical reductionist models struggle to explain. As you consider these possibilities, reflect on your own experiences of the relationship between mental state and physical well-being. Have you noticed how stress affects your immune function? How optimism influences your energy levels? Or how deep relaxation can produce measurable changes in heart rate and muscle tension? While these mind-body connections don't necessarily involve quantum effects, they do demonstrate that consciousness participates in biological processes in ways that transcend simple mechanical models of health and disease. The quantum perspective provides a framework for understanding how information processing in consciousness might influence information processing in biological systems. Recent advances in quantum biology have revealed that living systems actively exploit quantum effects for enhanced efficiency in processes like photosynthesis, enzyme function, and possibly even DNA repair. If biological systems can maintain quantum coherence for functional purposes, then it's conceivable that consciousness might influence these quantum biological processes in subtle ways. This doesn't mean that positive thinking cures cancer or that meditation alone can treat serious illness. Such claims lack scientific support and can cause tremendous harm. But it does suggest that the relationship between consciousness and health might involve quantum information processing that operates below the threshold of classical medical detection. Think about the implications of this possibility for your own approach to health and healing. While quantum effects don't replace the need for appropriate medical care, they might suggest that consciousness plays a more active role in biological processes than purely mechanical models would predict. We've journeyed through the strange territories where trusting quantum mechanics completely transforms our understanding of reality itself. From materials that break their own rules, to consciousness dancing with cosmic fields, from time crystals that defy thermodynamics to the possibility that awareness participates in the universe's quantum evolution. What emerges from this exploration isn't just a collection of fascinating phenomena, but an invitation to expand our relationship with mystery itself. The quantum world doesn't demand that we solve its puzzles or pin down its meanings. It simply asks us to remain open to possibilities that exceed our current capacity to imagine. Every breath you take involves quantum processes. Every moment of awareness might reflect quantum information processing that connect you to the fundamental structure of reality. In trusting quantum mechanics completely, we discover that we are not separate observers of a strange universe, but expressions of its deepest creative principles. The universe is far more wonderful, interconnected, and mysterious than we ever dared imagine. And perhaps that's exactly as it should be. Rest well, knowing that even in sleep, the quantum dance continues, and you are part of its eternal, beautiful choreography. If these quantum mysteries have stirred something in your subconscious, you might find our exploration of how these same principles speak through dreams. In quantum dreams, the hidden code, your subconscious, is desperate to reveal. Until we meet again in the endless mystery of possibility.